Hey everyone, I'm Steve from OpenZeppelin. In this video, I'm going to walk you through running a production Guardian instance. We'll cover what it is, how the production AWS stack is structured, how to manage your acknowledgement keys, how operator authentication works, how to use the operator dashboard, and how to get observability into your instance. This isn't a quick start, but more so a clear picture to reference and help you understand every moving part involved so you're ready to run your own Guardian deployment. Guardian evolves quickly, so throughout this video, I'll be using the various repos and documentation as the source of truth. You can find the links to them within the YouTube video description and our docs. And with that, let's get into it. Before we touch any infrastructure, let's go over the mental model. Miden accounts are private by default. On a public chain like Ethereum, anyone can read account state from the ledger. On Miden, the chain only stores a cryptographic commitment to your account state. The full state lives with you, locally. In fact, an account isn't tracked on chain at all until its first transaction. Before that, the network knows nothing about it. That privacy, it creates a coordination problem, though, with multiple devices or cosigners who holds and syncs the authoritative private state. Guardian offers an answer. It's an off-chain coordination and acknowledgement service for private account state. There are some key points to make with the trust model in action. When a user sets up an account, they define a set of cosigners and an M of N signing threshold among their own keys, say one of two. Either their hotkey or their cold key can authorize a state update. Guardian is not one of the signers in that group and is not counted in that threshold. Those are real users only. Guardian operates on a separate layer. Every delta or state change requires Guardian's acknowledgement signatures on top of the user's thresholds being satisfied. The flow is the user's threshold is met first, then Guardian signs the overall delta as a final acknowledgement that it's valid. And then from there, Guardian doesn't sign the same part of the user side. It provides a separate final signature over the whole delta. So in a one of two setup, if you lose your hotkey, or your cold key can still authorize actions, including migrating your account to a different Guardian instance or adding and removing cosigners. Users can also switch Guardian providers at any time by creating a switch Guardian proposal and creating the required signatures. Now, as an operator, you're running that acknowledgement layer. You control the Guardian instance, you hold the acknowledgement keys, and you decide who has dashboard access. Your security setup directly affects every user registered on your Guardian. Now that we've outlined a high-level framework of everything, let's look more into the Guardian stack. For this video, we're not doing a live AWS deploy, but everything I show you here is real architecture, the real commands, and real output from OpenZeppelin's own running Guardian instance. We'll be referencing the Guardian repo, as you can see here, and you can find the link again in the YouTube description details or the docs. Guardian ships a reference AWS deployment, and that's what we'll walk through today. Guardian is distributed as a Docker image, so you can run it on other infrastructure. But the AWS and Terraform path is a reference implementation, and the concepts translate even if the tooling doesn't. Compute, as you can see here, runs on ECS Fargate. Storage is RDS Postgres with RDS proxy in front of it as a connection pooler. RDS proxy is part of the production profile specifically. One hard production rule is that storage must be Postgres. The local Docker Compose setup uses file system storage and is fine for testing, but the production profile will refuse to start on it. And Postgres is what gives you the durable audit trail and lets you run more than one instance. When it comes to your secrets, like database credentials, acknowledgement keys, the operator allowlists, they live in the secrets manager. Here's exactly what the Terraform provisions there. We'll look at the operator secrets Terraform file. This can be found within the Guardian repo, as mentioned before. That's what we're actively working through. Each of these blocks is a secret that Terraform creates in Secret Manager on first deploy. Your database credentials, your ACK keys, and your operator allowlists, as mentioned before. Everything's declared here, version and code, and you can check it out further. Going back to this, every release ships a pre-built multi-architecture image to a public GitHub container registry. So most operators can pull directly without building. You can still push your own custom build to your own ECR if you need to. The whole infrastructure layer, autoscaling, RDS proxy, ALB, ECS, etc., they live as Terraform in the repo's infra directory. You can see it all here. The code is a reference that you can just walk through on your own time. The deploy workflow covers three main commands. Before we begin, AWS CLI authentication is required. From there, build builds the image and pushes it to your registry. Plan runs a Terraform plan so you can review exactly what's going to change before anything happens. Reviewing that plan is how you confirm nothing's going to be unintentionally destroyed. Deploy, skip build, applies it. Terraform picks up the image you already pushed in step 1, so nothing gets rebuilt. Beyond the core loop of things, status shows the current state of your deployment, and logs tails the output. Both are useful once you're live. OpenZeppelin runs live Guardian instances on testnet right now. Here's a real request against ours. Here you can see my local copy of the Guardian repo that we're working through and the AWS deploy script that covers the deploy workflow we've been talking about. We'll run 2 commands within our terminal down here. And here you'll notice that the commitment is Guardian's public identity. It's what clients use to verify they're talking to the right instance. A different operator running their own Guardian would have a different commitment. For the complete command set and authoritative variable reference, the repo docs and the production guide cover it in detail. Okay, so now let's talk about acknowledgement keys. There are 2, a Falcon key and an ECDSA key. Falcon is the post-quantum scheme Miden uses natively. ECDSA is supported alongside it. The most secure setup for the ECDSA key is to back it with AWS KMS. With KMS, the private key is generated inside KMS and never enters the Guardian process. Guardian signs by calling out to the service. That means, even in a security incident, an attacker can't extract the raw private key. There's an important thing to note though. KMS only supports ECDSA. It cannot hold the Falcon key. There's no hosted KMS backend for that scheme today. So the current recommended setup is KMS for ECDSA and secret managers for Falcon. Bootstrapping is a sequence you run before your first Terraform deploy. Crucially, these secrets are created outside of Terraform state, so that accidentally destroying or reapplying a stack can never wipe your keys. The sequence goes like this. First, bootstrap the KMS ECDSA key, then bootstrap the acknowledgement keys, or ACK keys, which generates the key material and stores it in the secrets manager, continuing to use KMS for the ECDSA side, then bootstrap the storage encryption key. So everything is encrypted at rest, and the sensitive parts can be manually edited. The scripts are also designed to be safe to rerun if something fails partway through. Let's take a quick glance at the actual Guardian repo and the production markdown file that you can find the bootstrapping and runbook details in. I'm just pointing you to this because as the project evolves, it's key to actually go to where you can find any updated details that you can follow along with when you're running your own instance. Once Guardian starts, it loads these values from Secrets Manager and comes up as a fresh identity stable instance. One important operational sequence to cover: if you ever replace your ACK keys, every account already registered on your Guardian will need to run a switch Guardian proposal to re-register with the new keys. You should plan this key rotation carefully. It's not some rolling update. Notice these return different commitments. There are 2 separate key pairs. Falcon is Miden's native post-quantum scheme. Miden Falcon accounts use the Falcon ACK. ECDSA is used for Miden ECDSA accounts and EVM accounts. Guardian runs both, so it can serve all account types. These are the commitments your users pin when they register on your instance, and that's why changing ACK keys is a coordinated event, not some routine rotation. Now, when it comes to auth paths, Guardian runs 2 separate authentication paths in the same process. The first is a per account auth. Every account holder signs their own requests with their own key. That's the client-facing API. The second is operator auth, which gates the dashboard routes. Operators authenticate against an allow list that you, the operator, control. The 2 are isolated. Operators never see account keys. Account holders never see operator keys. Operator sessions are cookie-based. Once you're authenticated, a session cookie carries your subsequent dashboard calls. Sessions last 8 hours. The challenge nonce issued during login has a 5-minute window, so the signing flow must complete within that window. After that, you're operating on the cookie until the session expires. Permissions are explicit and per operator. Today, the allow list grants dashboard read access and account pause permissions with a placeholder reserved for managing policies. That capability is coming. You define these permissions in the allow list before you start your Guardian instance. If you deploy via the AWS path, the allow list is populated into Secrets Manager. If you run via Docker, the operator's file is provided directly. Let's take a look at the operator JSON to get a better idea of what's going on. As you can see here, each entry has two fields, a public key, the full serialized Falcon public key for that operator, and a permissions array. Dashboard read gives read access to dashboard routes. Accounts pause is the write permission that allows this operator to freeze accounts. Add any other entry here before you start your instance, and Guardian hot reloads this file without a restart when it changes. Now let's go over account pausing a bit more. It's the key operator control available today. An operator with the right permission can freeze an account, and you're required to provide a reason when you do. That reason is stored and surfaced, so any attempt to act on the account knows why it was blocked. While an account is paused, it can't create proposals or push deltas. You can unpause the same way, immediately. Let's now begin to explore this pausing feature within the Guardian operator dashboard that Miden has built and others can choose to use or build their own. Here you can find the Guardian dashboard GitHub repo, which you can reference and work through on your own. It's hosted under the 0x Miden organization. And as mentioned before, you can use it as a reference or you can run your own instance and build your own. This dashboard is a separate self-hosted application. You pull the repo, follow the setup steps, and point it at your own Guardian instance. Let's now begin to explore this pausing feature within the Guardian operator dashboard. Miden has built this, and others can choose to use or build their own. Here you can see the GitHub repo for it under 0x Miden's organization. And here is an account detail page. We'll cover more about the dashboard in a second. But for the pausing aspect, you can see that the status is active here. And in the top right, an operator can actually freeze the account. So let's click that and say suspicious activity detected. Hit freeze. And now you can see the actual description is listed under the pause area here. If you go back to the accounts and look at the actual status of the different accounts now, you can see it is paused. Now, if someone tries to push a delta or create a proposal on this account, they'll get a 409 response, Guardian account paused, with the reason surfaced in the error body. Read operations still work, of course. The account can still be reconfigured, and that matters if you need to adjust signers while an account is frozen. Now, if we go ahead and try to unfreeze the account, you'll notice that it can be done immediately. Operators can also drive pause and unpause programmatically through the exposed npm and cargo packages, the same API the dashboard uses, just without the UI wrapper. So we'll see that in the next chapter in more detail. The operator dashboard, as I've shown you already, is its own separate application. It's a Next.js project with its own backend, and each operator self-hosts their own instance, pointed at their own Guardian URL. It consumes Guardian's dashboard endpoints, and under the hood uses OpenZeppelin's operator client package to talk to your instance. There are two auth layers stacked here. Clerk is the human sign-in layer, gating who can open the dashboard at all. Separately, the Guardian allow list is the operator key layer that gates what you can actually do against a given Guardian. You need both. Setup is 4 steps. Clone the Guardian dashboard repo, run the key generation script in the scripts directory. It gives you a Falcon key pair. The public key goes into your Guardian operator allow list. That's what Guardian uses to authenticate this dashboard instance. And the private key stays in your dashboard environment config. That's what the Next.js backend uses to sign challenge nonces, and it never leaves the server. Then configure Clerk for human sign-in and bring it up with Docker Compose. The dashboard README and the Miden dashboard guide in this repo have the exact commands. Now going back to the dashboard in the local host again, let's walk about it in more detail. You'll notice the read-only MVP label in the top corner. That reflects the current permissions tier. Write operations beyond pausing are coming, as mentioned before. The label will go away as the feature set expands. Now, going back to the account list, as mentioned before and shown before, you can view every registered account, their status at a glance, the authorization scheme each account uses, and recent activity. Accounts that are paused show a distinct indicator, as mentioned before, under status. And as we already saw before, when you click into an account itself, you can see further details. At the top, you have the account's current state commitment. This is the cryptographic fingerprint of its state as Guardian knows it. And below that is the authorized signers and their commitments and the signing threshold. And further down, the assets Guardian knows about from submitted transaction. Under the activity tab, the per account delta feeds show every state change for this account. Each delta has a status. Submitted in amber means Guardian has the delta, but the on-chain account state hasn't caught up yet. Confirmed in green means it's executed on-chain. Deltas that don't confirm within the retry window are eventually marked discarded. The default window is around 15 minutes and is configurable. You can filter by status. Submitted, confirmed, discarded, to zero in on just the pending or failed transactions across the whole instance. That's what you'd pull up if something looked off. A compliance and pause capability is coming, as mentioned, and you see when you click this tab. That's where operators will eventually define rules like transaction limits or KYC gates per account. But today, the live write operation is pausing, which we've covered already. The last piece is the operator client itself, for when a UI isn't the right tool. Monitoring scripts, automated checks, bulk operations, the OpenZeppelin operator client package wraps the same dashboard API the UI uses. It's the exact same API service. The dashboard is just a UI on top of it. Here I've ran the list accounts TypeScript file here, which is showcasing these features. The first line in the output is the auth handshake. Challenge is fetched, Falcon signature computed and verified, and session cookie set. Then the account list. Same accounts we just walked through in the dashboard, same data, but just a different interface, as you can see here. And this is the composable part. Set Guardian URL to any Guardian endpoint, your staging instance, production deployment, and this same script, same opera key, hits a different instance. That's the operator client in one command. The last piece of the operator stack is observability. Guardian exposes a Prometheus metrics endpoint, and the repo ships a ready-made Grafana dashboard in the guides directory. The team combined the observability setup into a single Docker compose example. So you can bring Prometheus and Grafana up alongside a Guardian instance you're already running. Guardian exposes the metrics exposition on port 9464, gated by a bearer token you configure. Prometheus scrapes it every 15 seconds. The bearer token here is a throwaway for local development. In production, you'd use a mounted secret rather than an inline value, and keep the port off any public interface. Look into the actual Guardian repo on my local machine, you can see that there is a observability subdirectory, and within it, you can find the Docker compose YAML file, as well as the Prometheus YAML file, and more. The dashboard JSON is pre-built and provisioned automatically. There is nothing to author. Now, let's jump over to Prometheus and take a look at more details. This is Prometheus. The targets page is the first thing to check. The Guardian target should show state up. If it's down, metrics won't flow to Grafana regardless of what the dashboard shows. Scrape duration is visible here as well. Now let's switch over to Grafana. Grafana opens straight to the Guardian server overview dashboard. Anonymous access is enabled for this local stack. In production, you put a real auth in front of it and never expose it on a public interface. Let's walk through things a little bit further. When we look at the overview side of things, the overview row, it's the headline where account count is displayed, in-flight proposals, overall HTTP request rate, and error percentage. The account count matches what you see in the operator dashboard, which is good. And if the HTTP 5xx panel shows no data, that's actually what you want. It means that 0 server errors have occurred, not a missing metric. Now, as we see here, within the HTTP and gRPC panels, they break down things by route, request rate, status code distribution, and latency at P50, P95, and P99. These are what you'd watch if something felt slow. You can see exactly which route is the bottleneck and what the tail latency looks like. Looking at one of these panels, even just the pub key and challenge requests from setup are showing up here. Route, response code distribution, and latency breakdown. This is how you catch a route running slow before your users notice. The storage section shows operation timing and throughput. The DB pool panels show connection pool saturation. This local stack runs Postgres, so these should be populated. On a production deployment, this is one of the key signals for knowing when to scale. If the pool is saturating, that's your cue to increase the connection limit or add instances. Scrolling down to here, Delta and proposal lifecycles will fill in once accounts are actively pushing transactions on chain. On a production instance, this is where you'd spot submission bottlenecks. Scrolling up, this is what Grafana gives you that the operator dashboard doesn't. Trends over time with flexible time range filtering. The operator dashboard shows you current state through REST endpoints. Grafana shows you what happened over the last hour, the last day, and lets you zoom into an incident window after the fact. That's what you want for spotting latency creep before it becomes a page, or reconstructing what happened during an incident. Because it's a standard metrics endpoint and a starter dashboard JSON file, you're free to adapt it. Add panels, change the layout, wire in your existing Grafana or Prometheus stack. The observability guide in the repo has a setup for pointing Prometheus at a Guardian instance you're already running. Now, we've gone through Guardian. It's set up, glance at its code base, and walk through the dashboard. In terms of development, the next big piece of the operator control surface is account level policies, rule-based controls that build on the pausing capability we covered today. That's in active development, and be sure to keep up to date with our docs as well as any other written guide material when it lands. Guardian and Miden are moving fast. The best reference throughout your deployment are the source materials mentioned. Links to all of these are in the video description: the Guardian repo, the Guardian dashboard repo, and the Miden Guardian docs, which you should definitely check out. Follow the latest releases and the production recommendations there.